Okay, welcome to this example. Says you want to obtain a sample to estimate a population proportion. Based on previous evidence, you believe the population proportion is approximately P equals 0.86. You would like to be 96% confident that your estimate is within 2% of the true population proportion. How large of a sample size is required? Okay, so what's going on here? So we're trying to estimate something ahead of time. So again, like if the medical science comes out with a new treatment for skin cancer, they want to know, how good is it going to work? How well is it going to work in the future? Like, we'll know 10 years from now, after we've given it to thousands and thousands of patients, we'll know, on average it cures um um 88% of the people that do the new skin cancer treatment are cured by it. Whatever it is, we'll know it in 10 years, but we'd like to estimate it ahead of time so that if it's real terrible, we won't waste our time in people's lives. So, okay, so how sure do you want to be? You would like to be 96% confident. That's how sure you want to be. There's always a chance of error, but you'll be 96% confident that your estimate is within 2% of the true population proportion. Excuse me. So you want to be within 2%. You don't want any more than 2% error. And you want to be 96% sure that you're right within 2% of what will eventually be known as the true percentage that are healed by the new cancer treatment. So the question is then, how large of a sample size is required? Like how many patients do you have to try it out on? If you're going to do a study to figure out, you got to do it to 100 patients, 1,000 patients, 10,000 patients. How many patients have to try out the new treatment to figure out if it's gonna to figure out what the percentage cured is going to be within 2% of what it'll really be, and we want to be 96% confident. Well, to do that, I'm going to go to the online calculator. Here's the notebook, unit 3 notes. Come on down, sample size. We have either percentage or mean average. So this one is percentage. Did you notice that? Back to the question. We want to estimate the true population proportion, percentage proportion, same thing. All right, come on down here. And so percentage proportion. I'm going to use the online calculator, sample size for a proportion. So I'm going to go to the online calculator. Come on down. Sample size for me, sample size for proportion. Click on that. There it is. It opens up. Okay. What are we gonna do? So we either have no estimate for P, choose that rated best, or we have an estimate. Do we have an estimate? Yeah, it says right here. Based on previous evidence, you believe the population proportion is approximately 0.86. So we have an estimate. We think it's about 0.86. So we go, oh, okay. So then I'm going to say click. We have an estimate for you. What is your estimate for P? Well, it's about 0.86. I'll type it in right there. Did you see that? About 8.86. Okay. And then you'd like to be 96% confident that your estimate is within 2%. Within 2%. Look at the notes. E is air within amount. That E stands for air. Or within, same thing. You want to be within that amount. You want that amount of air. So what was the air amount? Within, right here, within 2%. So the E is 0.02. Remember, it's a decimal. We always change percentages to decimals when we put them in the calculator. That means 2 places back. So 2% becomes 0.02. Confidence level, that's going to become a decimal also. Back to the question, 96% confident. So we go, okay, 0.96 decimal, and then we're going to calculate in 12. So we have to survey 1,270 patients if we want to be that sure. Let's see if that's right. That's how many people we got to include in our study. That's right. That's how many people. And that way we'll be 96% confident that we're able to estimate what the true percentage will be within 2%. If we give it to 1,270 patients. And so there we go.